Hello, I'm Marton, and we'll talk about today some architecture points and overview to make big data analytics accessible to small companies. And let's see, what is it? So about me, in Turgumuresh, I know 90% of the room, so I should not add new things here. I'm in BigQuery lately, and I got Google Cloud GDA last autumn, which is actually great for the city, as universities and other local entities have great access to pre-announced things from Google via me. Let's see what we have on the agenda. So we will look at the challenge, what the small companies are actually struggling with. We will have an architecture overview and strategy tricks, and we will talk about Google BigQuery here. So in my article, I described 3 principles that are reflecting the states of starting in a small company big data tools. And here, the first is that they need to identify, combine, and actually to manage multiple sources of data. First of all, small companies don't quite realize what this means. They are only seeing only one database, or at least maximum 2. And after that, they should have the talent to obtain advanced analytics from what they have. And the third point is that they should choose a technological option, architecture that for them is suitable. Big data nowadays doesn't mean things that often enterprises do, so only for small companies should do it. Why is that? We are living in an era where every company now is a software company, and by extension, a data company. So even a corner shop is a software company, as it has software parts of the business. So if you look at the legacy reporting system, where we have, in my example, some web and mobile front end, and we have a web server and maybe a cron job and some batch processing to build the reports, and we will end up with the reports. The problem with this is that in the background, it's dates to the insights. As cron jobs usually kicks in minutes, for example, every minute. Maybe we wrote a script that does some aggregate job, and we schedule it, and it runs for 4 hours, to say so. And also there is the batch processing, which is actually could be 3 days on some platforms. I see heads moving, so that's great. And often companies using Spark or big data major stuff, they are overlooking their possibilities. For example, they start a job, after 4 hours they get out of heap space. Bummer. They Google up something, they look on Stack Overflow, they find a patch, they apply it, start it again, runs 5 hours now, and again, the heap out of space, and so on. They are trying to fix their code to go further and further. Also, this leads to days to insights. So actually, data analysts and who actually needs this data gets delayed and eventually gets only in a couple of days. What we suggest, and actually what's our desired platform, is that we need a backend that's capable to handle all this stuff, and actually it should be real time. It should have the deep analytics part. It should be cost effective, as we will do this outside of our architecture in this presentation. It should allow running ad hoc reports without developers support. That means that they have their own tools, and data analysts can run business insight for it. And minimal engineering efforts is very important for small companies, as they often don't have people to actually do Spark and all this major stuff. And if it's SQL or JavaScript, that every company has personnel for those languages. And we suggest using Google BigQuery for as a backend. And what is BigQuery? It's analytics as a service, data warehouse, data lake, managed by Google. It means that it runs on their infrastructure. You are only giving your credit card to say so. You don't need to maintain it. It's infinitely scalable. It scales to petabytes. Disney, for example, it holds several petabytes of data in BigQuery to make big data analytics. And it has the SQL 2011 standard, which is very, very, very good. It has all those with statements, window functions, and JSON, and so on, opportunities that are no longer SQL standard, which is from 1993, which is Windows 3.1. So if you don't use SQL 2011, you are still using Windows 3.1 on the database side. And integrates with all the Google tools and Tableau and other data analyst interfaces that they actually drag and drop things there on the screen. And it has very, very decent pricing. I need to mention pricing because it's a managed service by Google. The trick is that they have three parts of the pricing. I put here, actually I start with the storage. So it's 20 for 1 terabyte, which is very, very small. And also the 1 terabyte of query is $5. And in case we skip some archive, it's terabytes. So for example, suppose that I run 100 terabytes of queries in a month, and I have a storage of 1 petabyte, it ends up the bill to $21,000, which with the $21,000, I cannot buy enough servers or racks to actually power that data. Architecting for the cloud. So for small companies, it's important to know that what they should do as first step. The first step is that on-premise, on their infrastructure, they need to place an ETL pipeline, which actually complements their system and actually copies some data out of their current infrastructure. And for example, here it passes to BigQuery. If you look at a complex diagram, and here for the logic, so let's say that here, for example, we have the front end, and here we have the reports and actually the people. It's very important to understand that people with their tools, I named a few here like Tableau quickly and Data Studio, can run reports using the tools on Google BigQuery and other systems. This means people. People are also here as developers, and developers should place in our article we detailed fluentd. It's an even cheaper router or collector, which is actually makes transparent for them to expand, export, and actually make the data out of their system in multiple places. And actually, it's a multiplier as well. So if I end up sending an event as a JSON line, for example, I can set up in Fluent the different rules that the same event gets to our servers, which is a simple pass-through proxy, or complementary, and it goes to BigQuery and also goes to cloud storage as an archive. Using the archive is very, very handy in the future because we will have a transaction of the events as they happened in a file archived, and maybe 5 years later, more big data tools are on the market and they want to replay 5-7 years of data, which means that they are able to take the file and actually replay the events as a stream as it happened. It's very important to understand what the stream here means. So stream is not the final metric, it's how it was actually happening in the code as well. If we move forward, we will see here fluentd used for four actions. I am able to transform some JSON keys I can copy that to file and to BigQuery the same event. And for the developer, here is the setup for the BigQuery, where actually I name the time field, and I can use day partition for the user itself. This is easy for day partition because if you touch 7 days of data, you are able to name the partitions, and it will be lower cost and better performance. So for small company to integrate BigQuery, they need to set up this one file, which is the minimal setup, and their data, the event itself, defined as a JSON, ends up in BigQuery. So where to use this? We should use this on exploring unstructured, but what is very important to use on analyzing data, and analyzing data what the traditional database cannot handle, or it's difficult to handle there. It's not a replacement to traditional DBs, so you have a copy and you're still using the framework and connect to the traditional DB. You just keep a copy of the data because we can afford with those prices, and you are able to do big queries. I mean, here you can write 2,000 lines of SQL and it will respond in 10 seconds, to say so. And what's important is that it integrates well with JavaScript. For example, I can write in my user-defined function a full JavaScript. Like, for example, I can take a natural language processing library and I can inline it there, and I can analyze the text that I kept in a column, for example. If you go forward, it's serverless, so you don't need to maintain deploys, management, and these things. So you are, for example, not running out of resources. It's just there. It just works for you. And you can store more data. That's very important for us as well. Because, for example, if you have a 5 GB of database with streaming and with all the events, you maybe generate 5 GB for every day of the service. Google Data Studio is an interface that combines multiple Google backends. And actually, here is an example that in the backend, it's all SQL queries to different tables. For example, in BigQuery or BigTable, they're products of Google. This concludes my presentation. Questions? Okay, I will be here all day, so you can find me in the networking break and we can discuss really every aspect of this. I have longer presentations for this stuff as well, on SlideShare, for example, and videos. Thank you.